Hi everyone, welcome to day 8 of Math 133. Today we're going to cover the Chapter 4 review, and that is on page 365 in your course pack, page 365. So you want to grab that, and uh, we're also, um, there's also a Chapter 4 project survey in Canvas. So the survey. Let's click on that, and I'll drop the link for that in the chat for you as well. Uh, the Chapter 4 survey is, we're not going to use the data yet, but we are going to be using it on next week, Thursday. So uh, next week on Thursday, we're going to do the Chapter 4 Project 2. Okay. So it's not that long. I just need the length of your forearm and your height in centimeters. So um, there's a link right here where you can click and see what it is in centimeters if you're measuring it in inches. So measure from your elbow to your wrist. Okay. So chapter 4 is all about linear regression, and that's when we have two quantitative columns of data. Okay. So if we have two numbers for everyone, so everyone is going to give me a number for your forearm length and a number for your height, we can see if those two numbers are related or not. Okay. All right. But uh, like I said, you have time to fill that out. We're going to use those numbers next week. Okay. Now that survey is not connected to Canvas, so if you do it, Canvas is not going to know that you did it, so it's still going to show as like an assignment. So as long as you did it, don't worry about it. I have to go in and mark who did the survey and who didn't. Okay, so um, so don't worry about like if it says like, oh, it's missing or it's late. Okay, as long as you did it, you're good. Okay, so today though is the chapter 4 review worksheet, which is on page 365. Okay. Um, and chapter 4 is all about linear regression. So if you click on the link in Canvas, it's going to bring you here, and there's a button that you can click on for this link, and that'll bring you to this document, which has all the different links for all the different worksheets. One that we're looking for is the Chapter 4 review, which is down here. There's a button for StatCrunch, and when you click on that, that will take you to a data set that we're going to be using today. Okay, so I'll drop that in the chat as well, so you don't have to go find it. It's right there. Okay. Um, so make sure you sign in, right? Sign into StatCrunch. Um, but if you're watching this on the video, I clicked on the Chapter 4 review worksheet. I clicked on where it says this link. I scrolled down to the Chapter 4 review and I clicked on StatCrunch. Okay. That way you don't have to type in all these numbers into StatCrunch. I mean, it's not going to take you that long. There's like 35 numbers, it'll take you like a minute or two. But if there were like 100 numbers here or 1,000, like a huge data set, like in real life, then I don't want you to have to type all that out, right? So, okay, so let's jump over here to page 365. Okay. So just like all of our worksheets, I'm going to go through and give you some hints on how to do some of the problems, some of the ones that I think are a little more challenging. And then we'll go back through and we'll stop the recording and we'll finish filling out the rest of the worksheet. Part of the reason why I do that is because I want you to be able to use this to study off of for the midterm, right? So the midterm is not for a couple more weeks. We're going to start the midterm. We'll start talking about the midterm next week on Thursday. We're going to start the sample midterm, okay? And we'll start talking about the midterm and what to expect, like how to take it and where you can take it and what you can have, okay? But anyway, as you're studying for the midterm, though, I don't want you to just look at the paper and be like, oh, well, the answer is this. Okay. I want you to know like why that is, and I want you to be able to say, okay, how did we get that answer? Okay, and that's why we go through and I give you hints on stuff. So all of the hints though today are going to be on page 255 for everything. Page 255 is in your exam notes packet. It's all about chapter 4. It's all about linear regression. Okay. So main thing is when we're in StatCrunch, if I want to calculate a linear regression, I need to do stat, regression, simple linear. Okay. So we've already started talking about this with our project, and we'll do more today, and we'll do more next time. Um, chapter 4, we're going to be using this for a while. Even though this is the chapter 4 review, we're going to make sure that you understand linear regression. So we're going to work on it a couple times. But anyway, so the main thing is everything is on page 255. Okay. All right, so which of the following could not be a correlation coefficient? So on Tuesday, we did a project where we were exploring the correlation coefficient, and you know, it's a number, right? And it could be negative, right? But one of these numbers in here, it is not allowed. And so James has it for us. It's this one, okay? Your correlation coefficient is going to fall somewhere on this number line. And the closer it is to 1 or -1, the better that correlation is. Okay. It means that your dots are going to lie, very close to the line. Okay. On the other hand, if it's somewhere near 0, then your dots are just all over the place. They're not close to the line. Okay. So it's not allowed to go past 1 and it's not allowed to go past -1. So this number right here, -1.03, is not possible. Good. In each case here, circle the label or circle the value of the strongest relationship and then put a box around the weakest. Okay. So for part A, which of these numbers would give us the strongest correlation coefficient, the strongest relationship? So James says it's this one, okay? So this one's negative, okay, but that's okay. So the closer it is to 1 or -1, the stronger the linear relationship, okay? So -0.75 would land right around here, which is a moderate negative, okay? So basically, ignoring the sign, so if you ignore the negative, which one is the biggest, okay? So this one is the biggest. Now we also need to put a box around the smallest one. So which is the weakest relationship? Thank you, Ryan. The weakest relationship is this one. This one is the one that's closest to 0. Okay. If you have this for your correlation coefficient, that means there's no linear relationship. Now that's for R. R squared. So R is called the correlation coefficient. And if you square it, you get what's called the coefficient of determination. And the coefficient of determination actually has, we'll talk about that a little later, okay, where we talk about like actually what that means, okay? But when you square a number, it has to be positive, okay? Because if it's a negative number and you square it, negative times a negative is positive. So your R squared is always positive. But still, if you have a number that is really close to 1 or really close to -1, when you square it like -0.9, when you square that, you get positive 0.81, which is also still really high. If you square a small number like 0, 0 squared is 0. It's going to still be small. So which of these ones is the strongest relationship? And we will circle it. Yep, you got it, Gabby. This one is the biggest. And we'll put a box around the smallest one. Which one's the smallest? Yeah, you got it. There we go. A box around that one. Okay. Um, that looks good. I'm going to skip through some of this. We'll come back and we'll fill those ones out. Let's jump to page 366, and we're going to look at number 5. Researchers want to know if food insecurity, which is the percent of households, so it's the percent of households that don't have enough food to eat. That's what food insecurity rate is. Um, what percent of households, you know, have inadequate food? They want to see if that affects the teen birth rate, births per thousand teen women in the U.S. Data is gathered from a random sample of states and shown below. Uh, so each row represents what? So it's important when you're collecting data to understand what each row is, okay? So each row here is two numbers, and those two numbers correspond to something, okay? They could correspond to like a year or a person, right? There could be a person or a household that has this food insecurity rate and this teen birth rate, right? But that's not the case here. What does each row in the table represent? James has it, states. Yep. Each row represents a state. So I don't know what state this one is. Maybe this one's Michigan, right? Michigan has a food insecurity rate of 10.8. 10.8% of the households in Michigan don't have enough food to eat. Okay. And their teen birth rate is 10.6 births per thousand teens. Okay. So I know that because it said we did a random sample of states. So you look at what your sample is or your population. If this had said we did a random sample of households or random sample of years, then that would be what we would put here. Okay. So each row here is a state. Okay. Now we don't have all 50 states because it's a sample. Okay. That's fine. I'm going to skip past that. So the equation of the regression line. So use X and Y. So this is on page 255 at the top. It says what buttons we click on in StatCrunch. Okay. So let's jump over to StatCrunch. Okay. I dropped the link in the chat already earlier. And we are going to look at the numbers in here. So these are the same numbers on the worksheet. Okay. And we're going to calculate the linear regression. We're going to calculate the equation of the line. So uh, we go to stat, regression, simple linear. Okay. Tell it which one's your X, which one's your Y, and we'll hit compute. Okay. And it's going to give you a whole bunch of different stuff. Okay. Now the equation of the line is this one right here with the equal sign. Okay. Um, now, in algebra class, we said that the equation of line is y equals mx plus b. Okay, mx plus b, where m is the slope because the word slope has an m in it, and b is the y-intercept because y-intercept has a b in it. Okay, that's just a joke. I don't know why they use m and b for the slope and the y-intercept. It makes no sense, but y equals mx plus b. Now, for a linear regression, we might actually write it as y hat equals mx plus b. Why do we put the little fancy hat on it? That's just to remind us that it's not the actual y value, it's a predicted y value. Okay. If you leave the hat off, and I will probably leave the hat off a couple times, it's not a big deal. Like I said, it's just a reminder to us that it's not, it's a prediction. Okay. So, all right. So we want to write out the equation of our line. Now, instead of putting the word teen birth, we'll just put y. Okay. So y equals and here's our mx plus b. Now, they put it in the other order, which is fine. You can write it out like that on your paper if you want to. Um, so the slope is the number attached to the x. The slope here is 2.061. Okay. The y-intercept is negative 11.67, right? So I'm going to switch the order around. You don't have to, but I like to have it in the other order. So I'm going to write y equals 2.061 x, and then minus 11.675. Okay. And I already dropped the hat off. So if you want to put the hat on, it's, yeah, Y hat. Okay. Okay, so I'm gonna skip past a couple of these. Interpret the coefficient of determination in the context of the situation. That's on page 255. Everything's on page 255 today, but this one's at the bottom. There's a script for that. So there's a script for interpreting the coefficient of determination. So you'll write out what R squared is, but you'll write it out as a percent of the total variation. You'll write out what Y is explained by the least squares regression line. Okay. This is the way I want you to write it, not the way that you might find it on like Google or like, you know, if you are using some AI that you're not supposed to. Okay. Write it the way that we have it on page 255. Okay. Um, all right. We'll skip past those. All right, so we're going to keep talking about this, so I'm not going to set that aside. Page 367, we're still talking about food insecurity versus teen birth rate data, okay? The slope, the y-intercept, the correlation coefficient, all these different things are these parameters or statistics. That depends on whether you have a population or whether you have a sample. So what do we have here? Parameters or statistics? Yeah, thank you, Ryan. It is statistics, okay? Because it says it's a random sample of states, okay? If it had said all states, then yeah, we would have said parameter. Find the slope of the regression line. So one of these numbers was the slope. Um, it's the number attached to x, okay? And you can write it in the other order if you want. If you write negative 11 plus 2.061, you have to make sure the x stays attached to the 2, okay, not the 11. So slope here is 2.061. Explain what it means in the context of the situation. So there's a script for that in the middle, okay? And so anytime you see the word explain or interpret, we want a sentence, okay? So I'm actually going to do this one with you this time um, uh, on the recording, okay? So the interpretation of the slope is this. If, and then you write out what x is, increases by 1, and then you write out the units of x. Then you write out what y is expected to increase or decrease by approximately, and then you write out what the slope is with the units. So they actually wrote the equation of the line ax plus b instead of mx plus b. That's probably because slope has an a in it. I don't know. I'm just making it's either way is fine. Okay. So I'm going to actually write that out. Okay. So if, and then write out what x is. If food insecurity increases by 1, it's always increases by 1. So if x increases by 1, and then what is the unit for x? So the unit for x is percent. Okay, 1%. If food insecurity increases by 1%, then we write out what y is. Y is expected. Oh, 2. All right. Now we write increase or decrease depending on the direction of the slope. If it's a positive slope, it means increase. If it's a negative slope, we'll write decrease. So in our case, we have a positive slope, positive 2.061. So increase by approximately, and then we write out what the A value is. Now, I don't quite agree with this because if your slope is negative, you don't write the negative. You write increase or decrease depending on whether it's a positive or negative. So just drop the sign. So in this case, there's no negative. So I'm not going to drop the negative. There's no negative to drop, but you would drop the negative here because you've already put decrease. Okay. We're not going to worry about that right now. We just write out what the slope value is, and then you put the units for y. The units are births per thousand teens. And that's what the slope means. So if if food insecurity increases by 1%, then teen birth rate is expected to increase by approximately 2.061 births per thousand teens. Okay? Find the y-intercept of the regression line and give 3 decimal places. Explain why the y-intercept does not make sense in the context of the situation. So this also has a script. Page 255. There's a script there. Uh, Sorry, Gabby, I'm not wasn't clear on your comment. What does Cindy do that I don't? Cindy, you have something special that I
Sorry. Instead of approximately, she puts about. Yeah,
Oh,
that.
oh, can you put about here? That's fine. Yeah. So, um, I was just following what the script says. Yeah, you can change it to about. That's fine. Those mean the same thing. So, when you're writing out the explanation or the interpretation of what the slope means, you don't have to follow the script. Okay. The script is just there to help you. Okay. This class is not about memorization. It's not about following the steps exactly. It's about understanding what the numbers mean. And so if you want to write out in your own words what the slope means, that's fine as long as you can describe it and explain it. The script is just there to help you. Okay, if you're looking at this and you're like, I don't know what the 2.061 means. So yeah. All right, find the y-intercept. Mike's got it for me. 0, comma, negative 11.675. Now, don't just write 11.675, okay? Because the y-intercept is not a single number. The y-intercept is a point on the line, okay? So, here's our line. Here's all of our dots here's all of our states. Some of the dots are right on the line. Some of them are off the line. This one's way off the line, okay? The y-intercept is where the line hits the y-axis, okay? So that is a point. It's an x comma y. If I hover over any of these points, there's two numbers there. This is the point 10 comma 9 or 10.9 comma 10.4, okay? Or vice versa. I might have said that in the wrong order. But anyway, so uh, now the x value is always 0, okay, for the y-intercept because by definition, the line where the line hits the y-axis always has an x value of 0, but make sure you write it out, otherwise you're going to lose points, okay? Okay, so explain why the y-intercept does not make sense in the context of the situation. So there's actually two scripts for the y-intercept. One is when x is 0, y is expected to be approximately this, okay? That's if the y-intercept does make sense. Most of the time, that's not the case, okay? Uh, the alternative interpretation, this is the one we're going to use when the y-intercept makes no sense. You're going to write impossible for, and then you're going to write out what's impossible, okay? Usually it's that x can't be 0, okay? Um, so for this one, so let's look at our numbers here. So this is 9 right here. So if I was to extend this line out, 0 is going to be way over here, right? 15, 14, 13. 0 is going to be way over here. That's very far away from the rest of the data. And so one of the reasons why 0 doesn't make sense in this case is because it's very far outside the range of our data. Okay. Our numbers go from like 9 to 15 or from like 5 up to 20 for teen birth rate. Okay. So when you're looking at linear regression gives you the ability to predict what is going to happen if you have this value, what's the other value going to be? Okay. And we'll see that in a little bit. But um, when you are measuring things inside of your range, that's called interpolation, okay? When you try to extend your line outside your range, that's called extrapolation. Interpolation is very accurate. Interpolation is a very good way to predict things. Often people try to do extrapolation where they try to take that same pattern and extend it into the future because we don't know what's going to happen. But if you go too far out, maybe this isn't actually supposed to be a line. Maybe it's actually supposed to be some other kind of shape like a curve, okay? If you zoom in close enough to any curved line, it looks straight, okay? Anyway, so let's go back. Let's actually fill this in. So, why does the y-intercept not make sense? We're going to say impossible for, and so it's impossible for, yeah, Kelly's got it. Impossible for a state to have 0% food insecurity. Ins- Um, if a state has no insecurity, that means every single household has enough food to eat. And unfortunately, we know that there is homelessness. Every state has people that are not able to buy adequate food. Okay, so this is never going to happen. Okay. Now, Mike pointed out that there's actually a second answer here. So it's not just the 0 that's the problem. This one, -11, is also a problem because it's impossible, and you don't have to write this out. So what I've written here is the answer. Okay, so we can say we're done. Okay, but you could have also said instead impossible for uh, teen birth rate to be negative, right? You can't say that a state has -11 births per 1,000 teens. That doesn't make any sense. How do you have negative babies, -11 births? Yeah, so either of those answers is fine. Okay. Oh my goodness, Corbin. Okay. For New Hampshire, y equals 4.6. Find x using the linear regression equation. Show your work, give one decimal place, and units. Okay, so New Hampshire y is 4.6. So we want to find x. So let's write out our equation. Y hat equals 2.061 x minus 11.675. Okay, so that's the equation we have, and they gave us y. Now, actually, they gave us the actual y. So yeah, I'm gonna, like I said, not gonna worry about whether it has a hat or not. Um, but they gave us y in this case, so 4.6. Okay. Um, if you wrote it in pen, you'll have to write below your line 4.6 and blah blah blah, right? We don't do math in pen, right? Pencil always when you're doing math. Should be a requirement. Anyway. So we have this equation, and I just plugged in what y was. Now I need to find x. I need to solve for x, okay? Be careful when you're plugging in these kind of numbers because sometimes, so here it's obvious because they said y equals, but if they had said teen birth rate equals 4.6, does that go in x or does that go in y? So just pay attention when you're substituting in. Okay, so we need to do some algebra. So I have the x here, and I have the 2.06, and I have the 11.67. I need to move both of those over to the other side. So which one do I move first? What do I need to do first to solve for x? Yeah, I need to get rid of this negative 11 first. So if you remember PEMDAS, PEMDAS is the order of operations. It's the way that we calculate numbers. But when you're doing algebra and you're solving for x, you go the other direction. So in other words, you get rid of the subtraction first. Okay. So to get rid of a subtraction, you add 11.675 and you do it to both sides. You can do anything you want as long as you do it to both sides, right? You got to be fair. So I can cancel both of these. And so in your calculator, 4.6 plus 11.65 is 16.275. Okay. Now I need to get rid of the 2.061. So what do I need to do? How do I cancel the 2.061? Divide, right? This was minus, so the opposite is plus. This is 2.061 times x, so the opposite of times is divide. All right, so these will cancel out. And all you'll have left is x. So we get x equals, I'm not going to do that one in my head. Somebody, 16.275 divided by 2.061. Thank you, Mike. We need 7.8, 7.9. All right, so yeah, one decimal place and units. So what was the units on x? Percent. You guys got it. All right. So New Hampshire has a teen birth rate of 4.6 births per 1,000 teens. X is 7.9% food insecurity. Explain why the values above are most likely outside the scope of the model. So earlier I was using the word range, but technically I shouldn't have been using the word range. Range is a different term, right? Range is our maximum minus our minimum, okay? But you can kind of understand what I mean by that. Uh, the actual term is outside the scope of the model. So what does this mean? So looking at our numbers, uh, x is 7.9. Are any of these numbers here close to 7.9? I mean, I guess you could say they're close, but no, all of these numbers are bigger than 7.9. Okay. The smallest one is 9.1, right? This one's 13. So looking at our graph, so all of these dots are in this range, right? If I extended this line out, so if I extended this our x-axis out, here's 8, here's 7. So 7.9 is like right here. And then 4 points. So our dot for New Hampshire would be somewhere around here. Okay. That's not in the middle of all the other dots. So this is considered outside the scope. And as I said a second ago, this would be extrapolation. And the problem with that is extrapolation is not always accurate, okay? Partly because you're using a pattern here and you're trying to extend it out. Maybe, like I said, maybe this line isn't supposed to be a line. Maybe it's supposed to be some kind of curve, okay? And that's going to make it so that my dot is way far away from that line, right? Right now, if I extended the line like this, okay, it's kind of close, okay? But anyway, so let's go back and answer the question. So, explain why the values above are most likely outside the scope of the model. Because none of the uh, none of the food insecurity rates are close to 7.9%. Okay. Or you could have said 7.9% food insecurity rate is much lower than for the other states. Okay. And you could also, you didn't have to just look at the X, you could have also looked at the Y. Are any of these Y values close to 4.6? I mean, this one's 5.8, but all of these Y values are higher than 4.6. So you could have instead said 4.6 is much lower than for the other states. Okay. Either of these answers is fine. Okay. We're still talking about that data set. So page 366, we're still looking at food insecurity. For Alaska, X is 10.4. Find Y using the linear regression equation and interpret both values in the context of the situation. Okay, so once again, our equation was Y hat equals 2.061, but now I have what X is. 1.675. So we'll plug in our X, and now we can calculate Y. So here, I don't need to do any algebra. I just need to pull up my calculator and I get 9.759. We need a one decimal place. All right, whatever. 9.8. And units. Okay. uh, interpret both values in the context of the situation. So there's not a script for this. You just have to write it out. Just use logic, right? So just write out what Alaska has. You say Alaska has a food insecurity rate of 10.4% and approximately, or about, if you want, and about 9.8 births per thousand teens, teen birth rate. Okay. Alaska has a food insecurity rate of 10.4% and approximately 9.8 births per thousand teens, teen birth rate. Okay. Now, why did I write approximately? Because, this is not the actual y value. This is y hat. Okay. It's the prediction. Uh, does Alaska actually have that teen birth rate? Maybe, but probably not, right? Because, looking back over here on our line, um, this point right here is right on the line. But most of these points are close to the line. They're not perfectly on it. This one's way off. Okay. So, the line, if we were looking at, okay, what was it? It was 10.4. So if this one right here was Alaska, it's going to predict something on the line. It's going to predict the point that's closest to that one. But it's not going to be perfect. So that's what the next question is asking. It's asking you to find the residual. Residual is how far off were we with our prediction? Okay. So the actual teen birth rate for Alaska was 6.9 births per 1,000 teens. Okay. Find the residual. So our estimate was 9.8. We were incorrect. Okay. So there is a formula for this. Page 255 at the bottom for residual. And it's just your actual y value minus your y hat, your prediction. Okay. So that's easy enough. Residual equals. So which one do I write first? The 6.9 or the 9.8? 16.9. Yep. Minus 9.8 in your calculator. 7.1. Give units. Now, your residual could be positive or negative, depending on whether the dot is above the line or below the line. Okay. Now, so in our case, our residual is positive. What does the residual imply about the situation? So Alaska is having more teen births than expected because the residual is negative. Well, it's not negative. Okay. For our case, it's positive. So it's not that one, and it's not that one. So it's either Alaska is having more teen births than expected, or Alaska is having fewer teen births than expected. So which one is it? More or fewer? Having more, yes. We predicted 9.8, but it's actually more. Number two. Okay. So earlier when we calculated this linear regression, we did stat, regression, simple linear, right? And then we had StatCrunch calculate the numbers for us. Okay. So we are not, so it gave us this, it gave us our equation, which is correct. Okay. But there is a formula for how to do linear regression. We're not going to talk about that in this class. We're not going to talk about like doing it by hand, just the same way that we're not going to calculate any standard deviations by hand, but we do need to understand how it did it and what's happening. Basically, we've got this scatter plot. We've got two columns of quantitative data, and when you have this, plot of all these numbers, we want to draw a line through them, and we want to draw the line that is going to minimize the residual. In other words, the residual is how far off the line they are. We want all the dots to be as close to the line as possible. So which line would that be? That's what is happening in the background, okay? So, if I had my dots all over like this, I wouldn't want to draw a line like that. These dots are way far away from that line, okay? I mean, this one here, this is an outlier, so that's going to really mess things up. But you're not going to be able to draw a perfect line, right? This is not a perfect correlation, okay? But that's basically what's happening is linear regression is trying to minimize the residual, okay? The total sum of how far off the line these points are. Okay, so last one right here, and then we'll stop the recording. We'll go back over the ones we missed. Fill out the correlation diagram fully, okay? Oh, does Cindy not like these? It says Isaiah said, Cindy, don't look. Did I do something wrong? I don't know. So, um, yeah, she hates them. Um, so we've determined that the teen birth rate and food insecurity have some kind of relationship. Okay, they have a correlation. Okay, so we're gonna write our X right here, and we're gonna write our Y right here. Okay. Um, and we've determined that there is a correlation between these. Okay. As this number goes up, this number also goes up. If this number is very low, then this number is also very low. Okay. Now that doesn't mean that we have causation. In the middle of page 255, it says correlation is not causation. Correlation is not causation because there are lurking variables, such as whatever. Okay. So that's what we're going to put up here is we're going to put one at least one of the lurking variables. Okay. So um, what we're saying is that food insecurity does not drive teen birth rate. If you have a state with very high food insecurity, so you have a lot of households that don't have enough food, does that mean that you just automatically have more pregnant teenagers? No. Having no food doesn't mean, okay, well, teenagers are going to go out and get pregnant. Okay. Same thing the other direction. If you have a lot of food, that doesn't stop teenagers from getting pregnant. Okay. There's a lurking variable that is going to cause both of these to be high. So what what would be something that would cause a state to have lots of food insecurity and lots of teen births? So Gabby's got it on the nose. So money or income or wealth, uh, education. Yep, Mike, you got it. So you only have to put one of these. You don't have to put all of them. But education is another one. Okay. So if you have a state that has a lot of money, then that means that people are going to have more money for food. And they're also going to have more money for contraceptives and education and, teaching teens about safe sex, right? So if you have if you have a state that has very little money, and that means that they don't have a lot of money for food, and they don't, and to you're also going to end up having a high teen birth rate, okay? And that is causation. Now, so correlation is not causation because there are lurking variables. There's things that we haven't even talked about that are going to drive these two, okay? So, uh, anyway, so there's that. Um, and we'll apologize to Cindy. So, okay, so that's the end of that one. I'm going to stop the recording. We'll go back and we'll fill in any of the questions that we skipped over. Okay.